Hey guys, Mr. Bowman here. Today's learning objective is in white, and we are learning to apply trigonometry to 3D context. So nothing new in this learning objective. We all know about trigonometry, and we all know about these 3D contexts from that Pythagoras Theory video. We're going to run through a quick scenario regarding the example I've got on the screen, and I'm just going to show you the techniques and some of the tricks of the trade to get into these types of 3D questions. Before we get on with the question, I just want to remind us the trick with these questions. It's all about pulling the 2D triangles from your 3D shapes. So don't underestimate the importance of drawing on your diagrams, redrawing the triangles that you see within that shape. Visualizing it from other angles is going to be really, really important as well. So don't forget about that. Visualizing, a super important skill, and it is something that that as a teacher, it's really a difficult thing to teach students. But let's get into the question here. And the thing I'm trying to calculate, I've been asked to calculate, and this here might be new to some of us, angle BFC. And I'll show you what I mean by that on the diagram. So first step, draw it on your diagram. Here's B, here's F, here's C. So if you go from B to F, and then F to C, it would be that angle sitting in here. That's the angle I'm interested in calculating. And our first step would be to draw that triangle. So I'm going to go up, I'm going to go across, and I'm going to go down. The next step, I try to identify that right angle, and that's going to be down by C. That's the corner or square-like portion of it. There we go. So that there is C. Up the top here is B. We've got 3 centimeters along here, and F is in the bottom corner. And we've been asked to calculate this angle in the middle. I'm just going to call that X for now. The only issue with this particular question is we're missing one of those other 2 sides. We need to know 2 sides to be able to calculate that angle. So at the moment, we don't have enough information. So our job is, well, can we find another triangle somewhere to then be able to calculate one of those 2 sides? And this time around we can. I'm going to just change pen colors. Maybe I'll use the green pen, and we can see along the bottom it's actually already created for us. F to C, C back to E, E back to F. This is the most common one we looked at for Pythagoras' theory, the triangle in the base of a shape. So let's go ahead and draw that triangle now. So this triangle does look a lot bigger. It's probably a bit taller. So the right angle will be down by corner E. The top there would be C, and there would be F. And we know that CE is 4 centimeters, and I know that FE is 5 centimeters. And the thing I'm liking about my diagrams is we can see here is FC, and here is FC on our second diagram. So we can see there's a link or a side of the triangle in common between those 2 triangles. So what we're going to do is I'm going to call CFY, and once I've calculated that, I can then put that here, and that will let me calculate that missing angle. So let's go ahead and calculate that. So step 1, FC like this means length FC, and we're using Pythagoras' theory in this. So there is a bit of crossover between trigonometry and Pythagoras' theory questions. So a squared, b squared, c squared, that's going to be equal to 4 squared plus 5 squared equals y squared. We then go ahead, evaluate, we calculate. So that's going to be 16 plus 25 equals y squared. That there, 16 plus 25, that looks like it's going to come to 41 equals y squared. Y is going to be equal to the square root of 41. I've got my calculator here just to see what that answer is. Just a reminder, every calculator is different, so if you do need help with the calculators, do ask your teachers for help. That there is going to be 6.4 centimeters and I rounded that to 1 decimal point. Your rounding can be different, that's all good. So now that we've got y, we've now got two sides of that triangle. So I'm going to write that up here. So that there is 6.4 centimeters. We can go ahead and use, we'll change pen colors, go back to yellow. We can go ahead and use trigonometry to do that. So FB, that's the hypotenuse. BC, that's the opposite. FC, that's the adjacent. Which side don't we care about? We don't care about this hypotenuse, meaning we're dealing with O and A. That's going to be tan. So tan angle equals O over A. We're then going to substitute. Our angle is unknown, and we've called that x. So tan x equals 3 over 6.4. We're then going to inverse tan both sides to be able to cancel out the tans. Now, those two tans cancel each other out, leaving the x by itself. So x will be equal to tan -1, 3 over 6.4. And again, we'll get into our calculator. Make sure your calculator's in the right setting. Make sure it's in degrees. And we'll be able to find that 3. So tan -1 divided by 3, 6.4. Pop that in, and I'm going to get 25.1 degrees. And again, I've rounded that to 1 decimal point. So hopefully you can see the steps that I've got here. And what that does mean is if we link that to our diagram, that initial there, that initial angle, the angle from the base of our triangular prism to FB up the top there, that there is at 21 or 25.1 degrees. And that makes sense because the picture we have hasn't got a sharp incline. So fairly happy with that answer. So hopefully you can kind of see the techniques that I've used, how I've tried to link the 3D diagram with 2D diagrams. Hopefully you can see the link in FC and FC within the two diagrams. And then we used our right angle Pythagoras Theory and trigonometry to help us solve this type of question. So thanks so much for watching, guys. This is a really challenging skill, so you're going to need to get into heaps and heaps of practice. And hopefully you saw we had Shelda pop up today. We'll see you next week. We'll see you next time.